This is John Black, super chemist. We're going to try to make some hydrogen today. I want to just see the experiment, maybe skip over to the middle of the video and you'll see that. Alright, well the first thing I want to go over is a little bit about hydrogen. One thing is it is a metal, okay? I don't care what any books, I'm sure there's lots of books that say hydrogen is not a metal. I don't care what they say. To me, hydrogen is a metal, alright? 75% of all baryonic matter is hydrogen, and 99.98% of all that hydrogen is protium. Okay, now I went over this in my protonation video, but I'm going to go over it again. 99.98, that's pretty much 100%. Okay, so anytime you think of hydrogen, you should be thinking of protium. Okay, you can see we like to think of it as everything being evened off, you know, one electron, one proton, one neutron. But that's not the case. You know, there's always an exception to the rule, and this is one of those exceptions. All right. So this is what you normally have. Now, if you take an electron off there, what are you left with? You're left with a proton. That's it. You're not left with a proton and a neutron. So anyways, this is protium, deuterium, tritium. You can see each one, 0 neutrons, 1 neutron, 2 neutrons. This is what's considered heavy water. When you have heavy water, your hydrogens are deuterium. And tritium is radioactive. I think it decays down to helium-3. I'm not sure. I should have looked that up. Now, there's a million ways to make hydrogen. All right, I'm going to try to make it the unique way. Most people just put a metal in an acid, and you get salt wet. You also get hydrogen. Here's a little example. You put some zinc in some hydrochloric acid. The hydrogen comes off as hydrogen, and these two stick together and make your salt, zinc chloride. Now I didn't balance any of these equations. You can see there's 2 H's here and only 1 there. I'm just trying to give you the gist of it. I'm sure all of you have seen people put sodium in or potassium in water, and it makes a fire, and you know what I mean, it sparks and that. That's another way to make hydrogen. That's what's actually sparking the hydrogen you make. You throw some sodium in some water, you get a hydroxide. You get sodium hydroxide, and you get your hydrogen. It's so exothermic, it sometimes catches the hydrogen on fire. Okay. Now I'm going to do it a different way, all right? And the reason why is because you can learn a word here. It's called amphoteric. Now some metals dissolve in acid, some metals dissolve in hydroxide, which is a base, but some dissolve in both. And aluminum, that's an example. Aluminum is amphoteric, and it will dissolve in both acid and base. All right. Now, supposedly, aluminum is so reactive that you can actually just put it in some water, and it will do the same thing as the sodium, but not as strong of a reaction. But aluminum almost instantaneously forms a passive layer of aluminum oxide, and so you need to put in some sodium hydroxide to get rid of that aluminum oxide on the outside. You know what I mean? And once that eats it away, then your water and your metal can react. And here's the equation. It is balanced. I have 2 equations here because some people write it this way, some people write it that way. Basically, it's the same thing. You got 1 sodium, 1 sodium, 1 aluminum, 1 aluminum. The only difference is you have some ligands here, okay? And I believe they're water ligands. But if you look down here, look at here. Now, if you had 4 OHs, 1, 2, 3, 4, you can see I circled this one H2O and this other H2O, right? So what are you left with? You're left with 2 O's. That's exactly what's on this formula. So basically they're saying you have 2 O's, but you have also 2 water ligands in this formula here, okay? So it's basically the same formula. It's just one is telling you have ligands and one is not, okay? So I'm just going to blow up a balloon, and I'm not going to make a lot of hydrogen. I'm just going to show you, you know, what the deal is. All right, here's my stoichiometry and what I'm thinking. I just want to blow up 1 balloon, so I don't want to go crazy on this, okay? Now, if you watch my videos on what a mole is, you'll understand what I'm saying. Aluminum is 27 grams per mole. This is 40 grams per mole. And you need 2 of each. Same over here. This is 2 grams a mole. Wait a second. Yeah, 2 grams a mole. I actually did this backwards. But you can see I took 2 times the molar weight of that, 2 times the molar mass of that, and 3 times the molar mass of this, right? And that gets me all my grams. I need 54 grams of this, 80 grams of that, and I can make 6 grams of hydrogen, okay? But 6 grams of hydrogen, oh man, that's like 3 moles, man. 3 moles. 1 mole of gas is 22 liters. 3 moles, that's going to be like 66, 68, 9 liters. That's a lot. I do not want to make that much, okay? So let's get this down to a 1 mole thing, all right? This is 3 moles, so I divided everything by a third, right? I got 18 grams of this, 26.7 grams of that will make 2 grams of this, and 2 grams is 1 mole, okay? Now 1 mole is 22.4 liters. That's still a lot. That is a very lot. Now, to do easy math, if I take it down by a tenth, I could just move the decimal over. See how I moved the decimal over on all of these so that I get a new number, right? Now I have 1.8, 2.67, and that is going to make a tenth of this, which is 2.4 liters. Now I want a little bit more than that. Because I figure I'm going to fill up the apparatus is going to take at least 2 liters, and then another 2.8 liters to fill up the balloon. So I double it. If I double these thingies, now instead of 2.4 liters, I'm going to get 4.8 liters, which is about exactly what I want. So times this by 2, times this by 2. Now if I get 3.6 grams of aluminum and 5.34 grams of sodium hydroxide, then I should get 4.8 liters of hydrogen, just enough to fill up the apparatus and fill up 1 balloon, okay? And that's how I'm doing my stoichiometry. Let's see what we got here. We got a round bottom flask with the aluminum in it, right? We got above it, we got a condenser because this is very exothermic, okay? I got an equalizing funnel right here. It's going to drip in the water with the sodium hydroxide in it. When that mixes, it's going to get real hot, okay? I don't want the water coming up, with the hydrogen. I just want hydrogen. So I put this condenser on. It should condense any water that boils up there and get it out of the way. Now, if you look at the top, you can see I got a little thing here where it can let it go out because the hydrogen is going to produce hydrogen, but you got to get the air out of there first. So I'm going to let it get out of there first. I'll close this up. I'll open this. And as you can see, it goes down to this balloon. I got a clamp on there. See? Let's turn on the pump. This is scary because I don't like hydrogen. It's very explosive. Oh, there it goes. It takes a while to eat up that oxide layer, that passivation layer there. Oh shit. It went up. And I stopped putting stuff in there because it's like, wow, I don't have to get too crazy. It's actually scary because, you get hydrogen all through your room, you get some kind of static discharge, hits your light bulb and there's, a little spark and boom, this stuff's going to go up. And it's making it bigger and bigger. You can see down here. Look at how it's boiling up. That thing is hot as heck. I'm running on my condenser in there. All the air would be, you can see, look. Alright, well, it stopped boiling, so I'm going to put another balloon in here. And here we go. Alright, I just wanted to add in that this right here, this sodium, aluminum, and then the 2 oxygens, that's called sodium aluminate. And I'm sure you're making more than that. I'm sure you're making some aluminum hydroxide, aluminum oxide hydroxide, aluminum oxide. And those might even react with the sodium hydroxide to make more sodium aluminate. My point is that you are making other things in small quantities. This is just the main thing you're making. And it's called sodium aluminate. And the other thing is when you take hydrogen and oxygen and you light them on fire like we did with the balloons, you're actually making water. That's the process to make water. 2 H2s and 1 O2 makes 2 water molecules. When you get the ratio of 2 hydrogens to 1 oxygen, then you have your best explosion, your biggest explosion, because all your hydrogen will be reacted with oxygen. The perfect ratio, like I made an HHO generator, which is basically through electrolysis. It makes hydrogen and oxygen. If you mix them together at that ratio, that is the perfect explosion ratio. It will make the biggest boom. And the last thing here is I just wanted to go back over amphoteric compound. Is any molecule or ion that can react both as an acid or as a base. And always remember, science is great.